We have a polynomial function right here, and it's very nice that they've already factored it for us. And they want us to find the zeros, then give the multiplicity of each zero, and state whether the graph crosses or bounces at each zero. So first thing we want to do is let's take this polynomial function and let's set it equal to 0. Okay, so if it did equal 0, what would you need to put right here to make the whole thing 0? The answer to that is 3. And what would you need to put right here to make the whole thing 0? And the answer to that is -5. Okay, so the 3, if you put in a 3, this turns to 0. Everything times 0 is 0. Okay, and the same thing for a -5. Put a -5 right here for x. This turns to 0, and it doesn't matter what everything else is. It all turns to 0. So my zeros are 3 and -5. All right, zeros are 3 and -5. Now they want to know the multiplicity. So the multiplicity multiplicity of each zero, we need to see how many times this factor happens. Right here, this factor only happens once. So the multiplicity of 3 is 1. Right here, this factor happens 3 times. So the multiplicity of this, -5, is 3. All right, now what does that mean? Well, at 3, when x is 3, since the multiplicity is odd, this is going to cross. It's going to cross right through. All right, and at -5, since the multiplicity is also odd, because 3 is an odd number, it is also going to cross through. And what happens is, at 3, it's going to cross through straight like this. At -5, it starts to flatten out, and it kind of snakes right before it crosses. Okay, the higher the number, the higher the multiplicity, the more it's going to hug that line. Okay, so if this gray line here was the x-intercept, you see that at 3 it's going to cross straight through, and here it's going to kind of hug the line a little bit before it crosses through and goes up. All right, now let me show you what this looks like if we graph it so you can see what the zeros are and what the multiplicities are and what I mean by crossing. All right, and this is a very crude sketch, but you can see that at -5 it kind of curves through, hugs that axis a little more, and here at 3 it just goes straight through. And you could graph this if you wanted using a graphing calculator or a Desmos graphing calculator, or even from knowing the end behavior of this polynomial function.